Which section?
3-2.
Oh, we finished 3-2.
That's all right. Just got a question from the homework. Oh, okay. All right. So this is the problem where they give you all these 63 and 3-2. They give you all these conditions. To get this special airline fare, you have to purchase your tickets between January 1st and February 15th, and so forth. Right? And then they give you several people. Like Wing Park, it says he's going to purchase a ticket on January 15th, so that's perfect. Between January 1st and February 15th. You also have to fly round trip between March 1st and April 1st, and he's going to fly on March 3rd and return on March 18th. So that looks good. You must depart on a Monday, Tuesday, or Wednesday. He's going to depart on a Monday, and you must return on a Tuesday, Wednesday, or Thursday. He's going to return on Tuesday. And stay over at least one Saturday, and he's there for more than a week. So he's good. So each person you just see, is there any of those conditions that they don't meet? Because you must meet all of those conditions. So that would be like an and. You must do this, and this, and this. And it's very difficult to make an and true because you have to make each piece of it true. Sort of like, so I know nowadays there's a lot of ways to look for scholarships. If you guys don't know, holy crap. You used to have to go to the counselor's office, and there was this huge book. And I opened the book, and I go, you must be a math major. All right. You must have this GPA. All right. You must be, all right, all right, all right. And the very last one was, you must be a woman. Okay. Put that first. So you eliminate most of your people. Right? Well, it actually happened. It was a true story. And I was like, oh, sweet. Oh, crap. And then I went to the next one. So it's an and statement. You have to do all these things to meet the requirements. So you guys kind of with me. So you just look at each person and see. The minute they don't meet, if they're supposed to leave on a Monday or Tuesday and they leave on a Wednesday, no good. Next. Right? Have you ever looked at special airline fares? My God, they got all these conditions. And you're like, shit, I don't know if I'm going to do that. If you've ever looked at that. Or you just go on and just pray. Pick you. Maybe that's the best price, I don't know. No? Or do you use kayak? Anybody know what kayak is? That's what I use. Kayak. All right. Is that good? Is that cool? Is that okay? All right. Anything else from homework? Because I'm sure you guys are. Some of you are averting thine eyes. You don't want to meet them. I don't know what that means. Hopefully, it doesn't mean you're not doing the homework. That would so desperately suck for you. Very bad way to be. So what's happening in the near future here? On Wednesday, I'm going to have a practice test. Monday, of course, you guys can take the day off. Right, because it's a holiday. Next Wednesday will be a review for the test, and then the following Monday is the test. You guys realize that's happening. All right. Yes, ma'am.
So, are we having a quiz on Wednesday as well on chapter 3?
Yes. So, I think I said all that in that email I sent out.
Okay.
Right? So, on Wednesday, we're having a quiz on the first part of 3. I'm going to take it through, I'm going to go through 3:3. So, all the stuff that you've seen through 3:3, you can see on the quiz on Wednesday. All right, is everybody with me so far? Okay, good, good, good. All right, I'm so enthused.
So you didn't lecture on 3-4, did you?
I sort of did. We talked about the idea of equivalent statements, so today we're going to start there. If there's no other questions from homework. So let's start there. Last time I showed you, I had you do a couple of truth tables, and we saw that they came out the same. And to tell you honestly, I can't remember if I actually said this, but the whole idea of that was that they're equivalent statements. So, for example, let's look at this, because this gets kind of interesting. So, real quick, recall these. These were two very fortunate things. Right, De Morgan. Not Captain De Morgan's, don't get excited. No, or don't be indifferent. Alright. No fellow Roman. We just got lucky on this, to be honest. It looks like a certain property of algebra, and it just looks like it. Makes it easy to remember. So I'm going to recall these, and then I'm going to have you do a third one that doesn't look like distribution at all. But this sort of looks like distribution. What does this come out to be? Does anybody remember? It sort of looks like distribution.
Not P and not Q.
So then this one's probably going to be not P. That's crazy. All right. So those look sort of like distribution in a way, right? So that's just lucky. It's the logic works and they look a certain way. Okay, cool. It's easy to remember. And real quick, a little thing about this. I don't know if you guys have noticed in the homework. Let's say P was I like math, and Q is I take Tylenol. What would this statement say in English? So this is a weird little thing in the homework. I haven't really said it directly yet. Sort of on purpose.
I don't
What
like
the hell would
math.
that mean? Well, what's that mean?
I like math and I like Tylenol.
I like math and
I take Tylenol.
I take Tylenol. This in English is it is false that. It is false that I like math and I like Tylenol. Right? Cool. So if that's false, now think about it and see why this makes sense. If this is false, I like math and I take Tylenol. What's a way that could be false? In fact, there's so many ways for that to be false, right? How can an and be false? If at least one of them is false, right? So either this one's false or that one's false. That's the way that can be false. Holy shit, that makes sense. Holy shit. Jeff, sense and math don't go together. What are you doing, man? I like it. So many guys are like, stop. All right. Now, here's what I want you guys to do. So this dude does not follow that lucky convention. All right. So what I want you to do is to do a truth table for this. I'll tell you what. Let me make this one. You'll really like this. One big truth table for this whole thing. I'll help you out. I'll put some parentheses in there for you. Because 3, 2, 3, 3, 3, 4, and 3, 5. No, not 3, 5. 3, 4. 3, 5 will be a brand new idea. Yeah. 3, 2, 3, 3, 3, 4. If you know how to construct truth tables, you're mostly golden. We've done several truth tables over the last few days of this class. So try to do this one. How many letters are in there?
2.
Total. Just 2. Good. So it's not a huge one. It's just a 4-part one. If you don't want to do this problem, you could just draw a duck or your favorite animal to make you think that you're doing the problem. Just kind of hang out. Some of you guys are like way ahead of you, man. Yes?
In that first part of the whiteboard there, I did those problems, I did the stuff inside the parentheses, and then I negated the whole thing.
Sure.
I basically just
When you made a truth table or something?
Right. So
Okay.
when I made a truth table, I just did like
Yeah.
P or Q.
P. Okay.
And then I just
You negated the
Yeah.
Beautiful.
That works.
Because that's exactly, specifically what this says.
Okay.
You could have converted that to this officially and made a truth table for this, but who cares? You would have gotten the same answer. Yeah. try to catch up here. So, very first little shortcut we can do is not rewrite P and Q. I already got them here. When is this guy going to be false?
When true, it is false.
Yeah, when I have T implies F, right? That's going to be a false statement. Everything else is going to be true. So in here, this is false. Everything else is true. Now what I really should have said there first was, what do we do first? Now why did I do that first? Because it's in parentheses. That makes sense. We know that from algebra, right? And what can I do with that next? And then I can look at the other side, right? So what's the next thing to do with this here? Negate it. So then what's going to happen? Yeah, false, true, false, false. I like it. So I'm here now. Okay, cool. Now what we're going to do over here, I might as well rewrite P because it's way the hell over there. So let me do this just so we can keep it straight. And then what's not Q? False, true, false, true. So and is only true when they're both true, or false when at least one is false. Either way you want to remember it. So and is only true when they're both true. They're true here, so everything else is false. I don't need those two anymore, right? Let me stop there for a second. So you're only ever comparing two things. I don't care how big, how many letters, how big the statement is. You only ever compare two things. And you know what each, the conditional, the biconditional, the conjunction, you know what they each want when they're only true, when they're only false, that kind of stuff. So putting those together, you can tackle anything I throw at you, you can tackle it. So now what do I finally do?
The biconditional.
Good, the biconditional here in the middle, and that is only true when they're the same, I like it, or false when they're different, whatever way you want to remember it. So where are they the same? Everywhere. So this is what's this called? It's always true. We call that a
Equivalent.
tautology.
Tautology.
Sort of like truthiness. This really is true, all this. Tautology. What does that really mean? That's equivalent to algebra. That's equivalent to me in algebra doing this. Algebra. You remember this? How do you solve this equation? Distribute. Subtract 2x. I love this. This is when people are like so nice to the x. They're like, no x, let me save. No, the x's are dead. Die, die. What's left? 2 equals 2. And I love when people just circle that. I've proven that 2 is 2. It's like, no. What does this mean? When is this true? When is this ever not true? When is 2 not 2? Never. Right? So that, do you guys remember this from algebra? Anybody? What's the answer to this? What's the answer? You don't remember this shit. What property is this? What property is this? Isn't this it's not even really an equation. It's a property, right? Isn't 2 times x plus 1 equal to 2x plus 2? Does it matter what x is? Doesn't matter what x is. No, I can just distribute and I get that. So this is an identity. This is all real numbers. All real numbers. Because the x is canceled. It doesn't matter what x is. So there, over there, that statement is the same thing as that statement. They are equivalent. It's always true. And in algebra, that statement means they're always true. That is a true statement. It's never not true. Shit, I was trying to show it something that you remember, but none of you remembered it. A few of you guys did. All right. All right. So what's interesting then, now let's take a look at what that says. This is the negation of a conditional. And it doesn't just distribute and the arrow becomes an up arrow or something freaky. It becomes an entirely different statement. But let me ask you this. One of the best ways to think about negating something is think about how to disprove this. Or even better, when would I be lying? If I said this, when would I be lying? That's what the opposite of it is. So if I said, if you make an A, then I will get you a car. When am I lying? don't be so specific. Just tell me in English. If I say, if you make an A, I'll get you a car. You make an A. Now, what would that be? What letter would that be? You made an A. But, and what was but again in Mathish? And I didn't get your car. Well, look. Isn't that what it says? So in English, it makes sense that that's the opposite of it. Right? It's not a distributive law. We don't have any logic distribution. We just have two statements that look like they're distributive. Makes it easier to remember. Does that look like distribution? Well, not. Arrow is obviously A. No, the hell's what? Right? That it's not distribution. It's just the way it works. It just, we're not lucky. It didn't look like something I'm used to. Oh well, too bad for us. Maybe. Alright, cool. I do teach math, so I am sort of used to sucking people's souls out. But some of you guys look like you're almost empty, right? Yeah, I'm sorry. Souls. Right. That was kind of scary. All right. All right. So the point of 3.4 is if you do a truth table with this biconditional and you come out with all truths, that really means that equals that. Remember this guy's a super equals? Because it works both ways. Just like in algebra, I can distribute that and get this. How do I go that way? I can take what can I take out? A 2, and then I'm left with that. So it works both ways, right? So that's like a super equals in a definition of something. So that's like a super equals. If it's true, that means that those are actually the same statement. They somehow mathematically equate to each other, just like these do. Okay, maybe. All right. The other big thing in section 3.4. So section 3.4, there'll be a lot of tables. There'll be tables with these biconditionals in them. You do the truth table like you always do, but then you step back, and if it's always true, that means they're equivalent statements. All right? All right, cool. And here's the other thing. So, and this is the big mistake people make with this statement, and we already talked about this. So remember, let's go back to my favorite. If you make an A, then I'll buy you a car. Alright. If this was true, it would have to be a Matchbox car. That's the best I can do. So let's say I bought you a car. Can you say anything for sure? Did you make an A? We talked about this, but see how quickly people forget. You're like, yeah, it says, no, it doesn't say that. If you make an A, then I'll buy you a car. I buy you a car. Did you make an A? I don't know. You could have and could have not, right? Remember, this is the whole point of this. So that's why, if I just turn this bad boy around, so here's your conditional. Yep. And this is on page 133. This, if I just turn this around, is the converse. And it's not necessarily the same as that. Stop there for a second. These are just definitions. I'm never as interested in definitions as working things out. But I want to tell you this. Then you have something called the inverse, which is not P implies not Q. And then you have something, the most interesting name yet, it's called the contrapositive. And that would be not Q implies not P. These two are equivalent. So let's see why. I don't buy you a car. Let's say I don't buy you a car. Can you say anything for sure? Can you definitely say something? I don't buy you a car.
Didn't make an
You must not have made an A, right? Isn't that what that says? I don't buy you a car, so you must not have made an A. So that's why these are equivalent, right? If this happens, this will definitely happen. So if this didn't happen, this must not have happened. They're equivalent to each other. Right? So the contrapositive and the original statement are equivalent. These guys are just weird little offshoots. You guys are like, oh, this takes the worst thing of English and the worst thing of math and puts it together. I love this chapter, Jeff. All right. And that's all 3-4 has for us. So before we leave 3-4, let me let you guys, I want to make sure you guys are all able to do these truth tables, because I hope you understand that the quiz on Wednesday will certainly have a few truth tables that you have to do. So for example, can you do this here? Oh, here's something more interesting. Oh, here we go. Perfect. Which one is it? Oh, there it is. Yeah, baby. So yummy. What will you definitely do last in that statement? The biconditional. It's the most powerful thing up there, right? And I helped you out a little bit with parenthesis placement in the other places. Pretty much because I had to. Which way to do these. How many letters are there? Shit, 3. So there's going to be how many? I really snapped some of you guys. How many parts are there going to be? 8, right? 2 times 2 times 2. Kick ass. So let me help you out a little bit. Alright, so the way this works, this guy goes insane. This guy's very calm. Maybe do him. And this guy is right in the middle. Come in. The worst thing you can do for yourself is to get all slanty with these things and be like, where's that coach? me try to catch up with you guys. Notice there's no knots up here, right? So I really don't have to rewrite any of the letters. I've got P, Q, and R already set up for all the rows. So for example, what's the very first thing I could do up here? Q and R, I love it. So go to any of the parentheses and do inside there first on either side of that super equals, right? So Q and R, so I'm looking at these two. The quickest way to make a mistake on these is to just look at the wrong columns, right? I think that happens. Q and R, and is only true when they're both true. Cool. So you find where they're both true at that row, and they're both true at this row. So it's going to be false everywhere else. Cool. So I need a lined board. So with your paper, it's really nice to keep yourself straight with which row is, right? Now I can do what? What's next? On this side, I can do what? Or. Now if you need to, you can rewrite people. Let's see if we can do this. Or is only false when they're both false. I like it. So you guys have desperately got to get those in your brain. If you know those, then truth tables are quick and easy. So I find where P and this are both false, and that would be false there. That's false. You put that under the or sign. Bam. It's in the same place over here. False, false. So the last three look to be false right here. Right? They're both false there, there. That's the only place where or can be false. They're both false. All the other ones, at least one of them is true. So all the other ones are true, 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 true. I'm done with you. All right, cool. If you have your own way of doing these truth tables, if you come up with some shortcuts, just make sure I can understand what you're doing. Don't just have the answer come out of nowhere. Oh, and please, dear God, this is not an acceptable letter. I love that. I've always got at least one, and they're like, oh, what was the right answer? No, you tell me what letter that is. No, you tell me that. Get out of here. I have to give you props for trying something. Over here, I can do each of these in parentheses first, right? We're used to that from algebra again. So, P or Q, or is only false when they're both false, and they're only both false at the last two, right? So P or Q, they're false at the last two. Are you guys with me? So looking at P and Q, they're only both false at the last two. So everywhere else is going to be true. I'm desperately trying to stay lined up. Then I can do P or R. Get an answer for that. P or R, they're only both false here and here. So here they're both false. Here they're both false. So true everywhere else, because at least one of them is true everywhere else. Whew. Okay, how are we doing so far? It's actually okay if this is kind of boring. That normally means you understand it. It's good. We get applications coming to us later. And then I can finally, now I can do the and between these two. And is only true, they're both true. I like it. So true, 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 and then the other ones are false. So these are all both true. So the whole thing, they're all both true. So I'm done with you. I'm done with you. I combine those two into this. So finally I can do this dude, right? There's the results of that part, that side. There's the results of that side. And biconditional is true when they're both the same. So it can be false, false, true, true. So biconditional is true when they're both the same. Are they ever not the same? No, they're always the same, right? So then this is a tautology, which means that this statement is equivalent to that statement. They're the same. And what does that sort of look like? It looks like distribution. Again, it's just lucky that it looks like distribution. Distribution is not a logic property. It's just lucky that the statements look like they're distributed. But you guys see like P or Q, P or R with an and in the middle? Bam. Looks interesting. I like it. Maybe. Okay. Nobody's fully asleep yet. So that's good. It's a good sign. All right. So we're going to get into 3.5, and then we're going to call it a day after that. Because next time I have some handouts from the last part of chapter 3. So let me just throw this at you and see what you think about this. This is very interesting. Now we're going to get into sort of adding statements together to see if they lead to something. So for example, let me start in English, and then we'll look at the symbolic arguments. If I am tall, I must duck. I am tall. Therefore, is there a conclusion I can come to? I must duck. Okay, cool. So I started off nice and easy. But I just want us to get used to the format of these arguments. All right. I'm giving, these two are what's known as premises. A premise here, a premise there, and then I try to come to a conclusion. And as long as these two together lead to this, that is a valid argument. So it has nothing to do with the validity of the statements themselves. So what would the symbolic form of this be? How to write this symbolically? I don't know if I have the right number of L's in the right place for that word. How to write this symbolically? How do you write, if I am tall, I must duck? I left out word then, which English often does, but we know it's there. So, I am tall, I can call that P. And if I am tall, then I must duck, and I can call I must duck Q. So what would that look like?
P arrow Q.
P arrow Q, so that's the first statement. If I am tall, then I must duck.
In parentheses.
What's in parentheses?
P arrow Q. Because then you're, and I
Nope.
am tall. No?
Nope. You ready? You could write it that way, but this is a better way to write it. So it's understood that this next one is and. In fact, if I had like 5 of these, I understand there's ands between all of them. Next would be, what's this? That's understood to be P. Therefore, that's a quick way to write therefore, just 3 dots. All right, the triangle UFO. No. Therefore, I must duck. And what's that?
Q.
Q. I like it. This is given the strange name, law of detachment. Detachment. So we'll live with that name. Sure. You weren't around when it was named, so we'll live with that. So it's sort of like plucking off, if this is there, then I can pluck off Q, and there it is. So I'm detaching that. Now somebody help me out. What did I say earlier was if the same as this? I'm giving a little list of things. So it was the same as that. So if I am tall, then I must duck. What's the only other definite thing I can say then? If you make an A, then I'll buy you a car. If I didn't buy you a car, then you didn't make an A. If you don't have to duck, then you must not be tall, right? So then this would be, and anybody remember what that was called? So we had converse, not the shoes, inverse, and then contrapositive. That's the one. Right, so the law of contraposition. Oh, shit. Well, that one says it's really the same as this, just not Q implies not P, not Q, therefore not P. Or you can write it less directly. You can have appear, P implies Q, not Q, therefore not P. Either way, because they're the same statement. This one and this one. Okay, maybe. What's really nice is they got all of these collected on page 144. If you want to see all these. Next time I'm going to have a little handout for this. All right, so what about this statement here? If I say this one I call, this is my own name for this. I call this the property. And math, A equals B, B equals C, therefore A equals C, right? I'm as old as you and you're as old as him, we're the same age. It's like, duh. So I call it the duh property, or the duh theorem, depending on where I am. So what this says is, P, if P then Q, if Q then R, therefore,
If P, then R.
if P then R. Cool. So this is like a link of events, these several events that are linked together. If this, then this. Oh shit, this happened, so that happened. Oh, then if this, then this. Oh shit, that happened. If this, then this. Oh shit, that happened. Right? So dominoes is the way I always think about it. I pluck the first domino, boom, and then it all falls down there. Cool. The right name for this, don't call it though, is the law of syllogism. But I like the duh property better. What was the disjunction again? Disjunction was which symbolic thing?
Or?
Yeah, it was the or, the logical, the or. Right? It's a disjunction, disjoint. This is so or shows up, P or Q, not Q. Therefore, it's P or Q. It ain't Q. Therefore, so a way to say this is I like Oreos or dirt. I don't like dirt. Therefore, yeah, if it's an or, to be true, one of them's got to be true, right? So when I'm setting up this argument, each of these I'm assuming to be true. And that, of course, in itself can be something you can attack. So there's two levels of attack you can have. Your argument is not good. It's not valid. This and this don't lead to the conclusion. So we'll look at some invalid things next. Or one of these things is just a not true statement. You're like, well, my argument is valid. And you're like, screw you. You just said that penguins like to eat radioactive carbonite. I think that's false. Right? And so the whole thing goes to hell. But this is true. This is a true statement. I do like Oreos or dirt. Thankfully, I don't like dirt. Therefore, I like Oreos. So symbolically, what can I put here at the end? Therefore, P. If it ain't Q, it must be P. P or Q. If it ain't Q, it must be P. Cool. I like it. So these are all things, these are all argument formats that are valid. So let's look at some that are invalid. So the first one that's invalid is the most common problem. It's called the fallacy of the converse. Right? Sounds like some strange foreign film. But this one says, if P then Q, Q, therefore P. Now, why is that a fallacy? Why is that not true?
Because it's not a biconditional.
Yeah, it's not a biconditional. Biconditional is the one that works in both directions. So again, I always go back to, if you make an A, then I'll buy you a car. I bought you a car. Did you necessarily make an A? No, because if you don't make an A, I can do whatever the hell I want to. I'm out of the contract. I can still do it if I want to or not. I'm just not bound to do something specific. I can do whatever the hell I want to. How we doing? Okay, maybe. And then the last little bit is the fallacy of the inverse, and that's why they talked about these guys, because these are, and trust me, what I'm going to try to do, I always want to do this, I'm going to look through some, I don't know if I'm going to find something, but every now and again I'll hear this or I'll see it written somewhere. These are often used on talk shows. You hear it on the radio, kind of like in the way people argue, and they say something that sounds right, but if you stop and think about it, no, that doesn't lead up to that. And what really sucks is when your conclusion is true, you just set up an argument that's not valid. It's not leading up to the statement, and that's the most frustrating thing in the world. You're like, it's true, but you haven't shown me, you haven't proven it yet. Oh crap. So the other one is the other fallacy. Well, so this is fallacy of the, what did I leave out? Inverse. Oh yeah. So this, you see how these are related? So if you make an A, then I will buy you a car. I bought you a car. You didn't necessarily make an A. If you make an A, then I'll buy you a car. You don't make an A. Do I definitely not? I can't buy you a car then? I can still buy a car. So see how these are really almost the same thing in a way? They're related into why they are wrong, both of them. The reason they're wrong is related. Cool. All right. So let's do this. Let's see what these actually look like. Just like in the earlier sections, there are going to be some problems with nothing but English in them. And there are going to be some problems with nothing but P's and Q's and R's. Algebra, logic. So for example, let's do something that's not just a law here. Something that's a little bit sideways. Here we go. That'll work. Actually, wait. Let me do one of these. No. Oh, all right. This will work. Let's start with this. This will work. So just went against what I said. Oh, wait, I already had that. All right, so what do you guys think? So the question says, is this valid or invalid? Why is it invalid?
Because it goes back to buying a car.
Good. All right, so you can argue it from two different standpoints. You can either reference the name of the fallacy. This is actually one of the fallacies. Or you can just argue it. You can set up a situation and say, no, this doesn't make sense. I like it. So if I ask you to explain, you can either reference the fallacy it is, if it is a fallacy, or you can give me a situation. Yes?
No, I was just going to say it was the inverse fallacy.
Okay, cool. I like it. So the, careful. Inverse fallacy would be not P implies not T. This will be the converse.
You must have those mixed up.
Remember correctly. I always get my inverse and converse switched. Well, all right. What are they? All right. Let me be careful. I was with you until I wasn't with you. If P implies T, not T, therefore not P. So let's slow down. Let's think about this. Because I actually meant one thing and then I wrote it differently. So let's go back to the car real quick. If you make an A, then I'll buy you a car. I didn't buy you a car. Therefore, you didn't make an A. So this is this valid or invalid? This is valid. Right? This is actually fine. This is the contrapositive. This one's fine. Because if I didn't get your car, then you definitely didn't get an A. If you got an A, then I would have lied to you. So for me, I always like to go back to that situation when I have conditional statements. I like to go back to the situation because it makes it something physical. I can actually see what's going on. Now, how do you think I would do this? This is coming back to what you said earlier. How would I do this problem? Because we don't have a law for this. There's a few different ways you can argue this. Let's see that. All right, hold that. Sure. Whew. There's no law for this, right? There's a lot going on in this statement. And you said something earlier that's actually a valid. They give you some examples in the book that do this. So if it's in the form of a law or a fallacy, I can just use those. There's no law or fallacy that involves the biconditional here, right? So this is if P then Q and if Q then P at the same time, because it goes both ways. if Q then R. So if I said if P then R, that would be valid. That's a form of the duh theorem. Let me stop there. But it doesn't say that. It says I'm disgusting. So how the hell do I check this out? What really connects this statement with that statement? What's true about these? They have to both... What connects these? What word is in there in the middle? So if I say, if I like math, then I am crazy. I like math. Therefore, blah. So what's in between these? If I like math, then I'm crazy. I like math. Are you just separate? To get the answer, I'm taking both of these together, right? So in the middle of these, like you said earlier, is an and. So if I wanted to write this out in one statement, so I can make a truth table for it, it would be this biconditional and this. Do those together lead me to this? Whew. So if I make a truth table and that's always true, then that's a valid argument. So that's another way to do these problems. If they don't match a law or a fallacy, I can go back and I can make a truth table. This is one where you almost have to make a truth table because there's so much going on here at the end. Right? There's a lot of crap there. Holy crap, I don't know. Shit. Okay, maybe. Or, now watch this. Let me see if you guys can understand what I'm about to do. We'll see. And then we'll call it a day. Not R by itself. Not R would imply what? So Q implies R. So what is not R? You guys can... if you make an A, then I'll buy a car. I didn't buy a car, therefore what must have happened? Good. So therefore not Q, right? Is that cool? So not R would imply not Q. Would not Q have to imply not P? See, so you can kind of work your way backwards sometimes with these. You can actually kind of do almost some kind of algebra on these things. So let me do this again. I want to connect it to this, and then see if it connects to this. Q implies R, therefore not R implies not Q. Not Q, does that imply not P? That's the step you got to be a little careful on. Right? Or you can make a truth table out of this, and I think, I'm pretty sure, yeah, they do. They have a couple of examples of making a truth table for these things. Like example 6. Cool. Alright. So next time, we're going to do 3.6, and we'll see if there's time for 3.7. I might have to make 3.7 extra credit, we'll see. I haven't officially said I have, so we'll talk about that next time. And next time I'll have your quizzes graded. That's right. That's right. So currently you have half credit in that bad boy. Make corrections.
That one didn't have anything like that.
Oh! I might not even see it. I think I looked at it. No. Thank you. Yeah. Alright. You want to email me so I can email you the practice test. You want to email me? That means good. This means make corrections. You currently have half credit. It's up to you to make corrections or not. They're not due till the day of the final, so you've got a little time. Okay. No. Homework correction. Due to the day of the final. It'll come to you.